Hello and welcome back to the continuation for the review of Unit 6, Quadratic Functions and Their Algebra. In the last video, we looked at the basics of quadratic functions such as their graphs, axis of symmetry, and so forth. And we also spent a lot of time looking at factoring in the zero product law because that's a lot of the basics for the rest of the quadratics unit. In fact, being able to factor and be able to apply the zero product law. In this video, we're going to look at solving quadratic inequalities, and then we're going to look at completing the square before finalizing our review by looking at the equations of circles and the equations of parabolas before summing up the most important things from Unit 6 that you should take from here. So let's get right into it. To solve a quadratic inequality, you're going to do something similar to the equations. Okay, but inequalities have less than or equal to, less than, greater than, equal to, or greater than. Okay, but we're still going to compare it to 0 and then factor it. So we're going to compare it to 0, make it equal to 0, and then we're going to factor it. Now when we factor it, we're not going to get solutions like we did with the equations. We're going to get something called critical values. Those critical values are going to be the start and end points of our interval of values for the x solutions to the inequality. Now, just a few things to note. Whenever you have something factored less than 0, or it could be noticed less than or equal to, we're going to always end up with a conjunction. Our answer is always going to be like this. Negative 7 is less than or equal to x is less than or equal to 3. Or negative 7 is less than x less than 3. We're going to have a conjunction. Whenever we see a less than 0, those critical values are going to give us that solution situation. Whenever we have something factored greater than 0 or greater than or equal to 0, we're going to have a disjunction. And that's going to be something like x is greater than or equal to, let's do less than first, less than or equal to 3, or x is greater than or equal to 7. Okay. You might also have x is less than 3 or x is greater than 7. And if you think about it, it relates to the graphs, right? If you have a graph of a positive parabola, because typically we want to factor it with a coefficient that's positive in the beginning. So if we have greater than 0, that means over here we have a disjunction, right? So looking at that graph, it's going in opposite directions. If we have less than 0, that's going to be a conjunction. It's going to be between two values. So there's a little graphical reason as to why this is going to be. So let's look at solving these inequalities. Now for the first example, you might think, okay, well it's already factored. X plus 5, those are factored for them. However, it's not compared to 0. So we have to factor it compared to 0. So I'm going to actually multiply that out to get x squared plus 5x, and I'm going to keep less than or equal to 14. But I want to make it equal to 0 on one side. So I'm going to subtract the 14 from both sides to give me this inequality. Now let's factor it. Two numbers that multiply to negative 14 to add to positive 5, while positive 7 and negative 2 do that. And this gives me critical values of negative 7 and 2. Critical values are negative 7 and 2. Those would be the solutions to the equation if it were equal to 0. But here they're called critical values. Now what I'm going to do is I want you to write your answer both on a number line and algebraically. Okay, so on a number line, you can just go ahead and put the negative 7 and the 2. You don't have to worry about the specific units between them because we want to just indicate that. And we have filled in circles because we have a less than or equal to. Whenever you have an equal to there, you're going to have filled in circles. If it was just strictly less than, they'd be open circles. Now because it is less than, that means we're going to have a conjunction. And we're going to write our answer algebraically as negative 7 is less than or equal to x is less than or equal to 2. Okay, so there's our answer to that quadratic inequality. Look at an example. This time notice I have a greater than, so it's probably going to be a disjunction. But let's see. We want to make sure it's compared to 0. So to do that, I'm going to bring everything over to the left because that's where my highest exponent is, and it's positive. So I'm going to subtract the 20x from both sides, and I'm going to add the 3 to both sides, give me 5x squared minus 51x plus 10 is greater than 0. Okay, well, notice here there's no common factor, so this is going to be one of those more challenging trinomial factorings. But notice there's only two numbers that multiply to 5, so we have 5x and 1x. We know for sure that those are going to be the starting points of each factor. The question now becomes, do we have 1 and 10, do we have 2 and 5, and where do they go? Because orders matters here because we have two different beginnings of each factor. I'm noticing if I do 50 and 1, that makes 51. So if I do a negative 10, that gives me negative 50. A negative 1, that would give me negative 1. So that totals up to negative 51x. Again, with these types of factoring, make sure you double check it by multiplying it out to see if you actually get the 5x squared minus 51x plus 10. You can probably do that mentally. That gives you 5x squared, negative 50x, negative 1x. That works. And then positive 10. This works. So we have critical values here of 1/5, positive 1/5, and positive 10. That's what we would get if you were to solve this equation. Equal to 0. So I'm going to put it on the number line first. Okay, the smallest first, so it's 1/5, and then the next one is going to be 10. And because there's no equal sign, I know they're going to be open circles above. And also because it's greater than, I know it's going to be a disjunction. So algebraically, I'm going to write x is less than 1/5 or x is greater than 10. Now notice I'm using the word or because you can't be both. You can't be less than 1/5 and greater than 10. The answer to the solution is that x could be less than 1/5 or it could be greater than 10. Okay, so the or is also an important thing to notice here. As always, pause the video as we go along to write down anything you need to. Okay, completing the square is an important skill to be able to know how to do because not only will it work with circles to find the center and radius of a circle, but it also works to help find the vertex of a parabola. Okay, so here we have two functions, and the basic idea of completing the square is you're going to isolate all the variable terms and then put the number term to the side. Okay, and you want to make it a perfect square. So let's say I have x squared plus 10x. Okay. Well, the question is, what do I add to here to make it a perfect square? Well, remember that when you have perfect squares, so if you had, for instance, x plus 12, and you square that out, you will get x squared, and you have to double it, and it gets 24x squared, it becomes 144. So whatever goes inside the parentheses has to always be half of what's in front of the x. So in this case, up above, it'd be a plus 5. But however, in order to make it a perfect square, I had to have a 25 there. Now to balance that off, I need to balance it off by subtracting 25. Now you do that when you're completing the square on the same side of an equal sign. Okay, and that's what we're doing here. When we're dealing with functions, we're dealing with everything on the same side of an equal sign. So I'm going to isolate the x squared and the 8x term. I'm going to write plus a blank. And then what I like to do is I like to go to the next steps to kind of figure out what to go in the blank for both spots. Okay, so we want to write something that's equivalent that has a perfect square. Okay, and half of 8 is positive 4, so I know it's going to be x plus 4 inside the parentheses as my perfect square. But in order to have an x plus 4 quantity squared, I need to square the 4 to get a 16. But I can't just add 16, I have to balance it off by subtracting 16. Okay. So this now becomes the x plus 4 squared, and I'm left with a negative 26 at the end. Notice this is now in vertex form. The vertex form of a parabola I'm going to use letters that you might have not have seen in those spots before, but this is generally what the vertex form is going to be. The vertex of the parabola, therefore, is the b comma c. That's the vertex. Okay. So if I'm looking for the vertex of this parabola, it's going to be negative 4 comma negative 26. There's the vertex of that quadratic function. Now this one was a fairly easy one to deal with because the leading coefficient was 1, okay, and we don't have to worry about it. But in the next example, we have a leading coefficient of negative 2. So what I'm going to do first, before doing anything, is I'm going to factor out negative 2. So I have a positive 1 in front of my x squared. So if I factor out negative 2, and again I'm just worrying about just the x terms, I'm left with x squared minus 3x, and I'm going to leave a little blank. Okay? I'm not going to do anything to that 5. That's going to be separate. Okay, I just want to complete the square for the x's. Now I have inside the parentheses something that I can complete the square to. So notice I'm going to keep the negative 2 there. Okay. But in order to complete the square here, I have to take half of the number in front of the x. Well, half of negative 3 is negative 3 halves. So you could have fractions. That's perfectly fine. You could have fractions. Negative 3 halves. And then to make it a perfect square, I have to square the negative 3 halves to give you 9/4. Now, you have to be careful in this case. Because we factored out that negative 2, we really didn't add 9/4 to both sides. We added really negative 2 times 9/4. So to account for that, which ends up being negative 9/2 when you reduce it, I have to add a 9/2 to cancel it off. Combine that with the 5, which is 10/2, we get 19/2. So you might want to maybe on the side write this as 10/2 plus 9/2. That makes 19/2. Remember, combining fractions, you can only do that if you have common denominators. So my final vertex form of this parabola is negative 2 parentheses x minus 3 halves squared plus 19 halves. So my vertex is going to be at 3 halves comma 19 halves. And notice, as decimals, these are nice decimals, so you could have written as 1.5 comma 9.5. That's the equivalent decimal coordinate pair for the vertex. Okay. So that's completing the square. Pause the video, write down anything you need to. Now let's look at the equations of circles. Equations of circles can be represented in various ways. The easiest way that we can graph them and find things about them is in what's called center-radius form. And that is when you have a center of h comma k and a radius of r, okay, the equation is x minus h squared plus y minus k squared is equal to r squared. That's the equation for a circle in center radius form, because from that form we can easily find the center and the radius. From the center and radius we can easily write in that form. So for instance, if I had a center of negative 6 comma 7 and a radius of let's do radius of 8, I can write my equation for my circle as x plus 6 squared plus y minus 7 squared is equal to 8 squared, which is 64. Okay, so that is an example of from center and radius we can go to the equation. From the equation you can go to center and radius as well. Because from the equation you can say, well, it's going to be negative 6 comma 7. Radius is going to be square root of 64, which is 8. Now, sometimes you're going to be given the equation of a circle where you have to apply the complete and the square method to find the center and radius, because it's not as clear in this equation, x squared plus y squared plus 8x minus 12y equals 20, what the center and radius are. And it's to be in this form. So what I'm going to do is I'm going to group all the x terms together, complete the square for the x's. I'm going to then group the y squares together, complete the square for the y's. And on the other side of the equal sign, I'm going to put all my number terms. Notice my number term is already on that side, so I don't have to worry about moving it. Okay. But if I group all the x squared, all the x terms together, I get x squared plus 8x, and I'm going to leave a little space to complete the square for the x's. So I took care of the x squared and the 8x. Group the y's together, so y squared minus 12y. Leave a little space to complete the square. Now, unlike in the last slide where we completed the square on the same side of the equation, we're going to do it on the opposite sides of the equation. So whatever we get on one side, we have to just add it to the other side to balance the equation. Okay, so this is the other form of completing the square. This is what you saw most likely in Common Core geometry last year. Now I'm going to go ahead and write it into the perfect squared form because I think going from here into the parentheses back to where you are in this line right here will help you figure out what we're going to add to each part. So inside the parentheses it's always going to be half of the coefficient in front of the variable, so it's going to be 4 for the x's. But I have to square the 4, giving me a 16, which I have to add to the right side as well. Now for the y's, half of negative 12 is negative 6. Notice I'm keeping the sign. Square the negative 6 gives me 36. Notice it's always positive here. So negative squared is always positive. So I have to add a 36 to the other side as well. Now adding 20 plus 16 plus 36 gives me 72. Now I have it in a form where I can easily find the center and radius of this circle. The center is going to be at negative 4, 6. And the radius, that was the center, the radius is going to be the square root of the 72. Not 72, but the square root, because this is equal to r squared. Don't forget, that's equal to r squared. Head to the square root of that number. Square root of 72, now the problem might ask you to reduce that further, so you have to find the highest perfect square that divides into 72, which is going to be 36 and 2. Multiply by 72, where you have 36 is the highest perfect square. So you could also rewrite the radius as 6 radical 2 in simplest radical form. But, you know, or if it says round to the nearest tenth, you'll notice that this gives us 8.48, 528, so forth. So you could say r is equal to 8.5. You know, if you're graphing it, it might make more sense to use the 8.5 than it would be the radical 72 or the 6 radical 2, because that doesn't really tell you much about where on the graph the radius goes to. But the 8.5 clearly does. Alright, pause the video now and write down anything you need to. Okay, now let's look at the equations of parabolas. Now the definition of parabola in terms of focus and directrix is that for some line in some point, the line being called the directrix and the point being called the focus, if you take all points that are the same distance from both of those parts, from the line and the point, the directrix and the focus, it creates a parabola. Now the vertical distance from a point to the parabola has to be the same as the distance from that point to the focus. So the point could be way up here, so it could be more of a diagonal. Okay, but those lengths are going to be the same. Obviously, they're going to be different lengths for different points in the parabola, because as you go further and further up parabola, you get further and further away from the directrix, right? Okay. But that's the general idea of the equation of a parabola. Now, if you have a focus located at the point A, comma B, and a directrix located at y equals, let's say, k, then the distance from a point on the parabola to the directrix is going to be y minus k, and the distance between a point AB and a point xy on the parabola is going to be x minus a squared plus y minus k squared, using the distance formula. Okay. But that looks a little nasty to work with because we're dealing with a square root with squares underneath. So if you square both sides, that actually gives us the equation that we should use to find the equation in standard form for a parabola. So I'm going to write the equation as y minus k squared is equal to x minus a squared plus y minus b squared. No, it's the exact same thing as the equation which represents the definition of a parabola. Okay, but it's much easier, I think, to work with, and it looks closely to the equation of a circle, right? Instead of an r squared, we have a y minus k squared. Okay, so let's look at an example. Okay, find the equation of the parabola with the focus 4, 9 and a directrix of y equals 5. Okay. Well, let's first look at the graph of this. Let's see what it kind of looks like. Here's a set of axes. Y equals 5 is roughly about here. So that'd be the directrix, y equals 5. And 4, 9 would be probably like right here. That's going to be the focus. Okay. So our parabola will look something like this. Okay. That's what our parabola is going to look like. Notice from the focus to the directrix, 9 to 5 is a total of 4 units, so therefore it has to be 2 units to get to the parabola, to the vertex of the parabola. And it's also going to be, since it's 4 units away, 4 units to the left and right from the focus to get to the points on the parabola. So when you're graphing them, those are some 3 critical points you should be easily able to find. However, when you get to the equation that we're going to get to, we could always plug it in our calculator and find the integer points on the graph. Okay, that will work. Alright, so let's start looking at the equation of, find the equation of this parabola. So the focus is 4, 9 and the directrix is y equals 5. So I'm going to start off with y minus 5 squared, because that comes from the directrix, equals x minus 4 squared plus y minus 9 squared. Okay, that came from the focus. Notice on one side the equal sign is everything to do with the directrix, and the other side the equal sign is everything to do with the focus. Now you may say, well, I have an equation there, I'm done. Okay, but a lot of the times these problems may ask you to find the equation in standard form, which is in the form y equals ax squared plus bx plus c. And maybe it may ask you to find the values of a, b, and c. It may ask you to find the value of a plus b minus c, whatever you get, whatever it says. Okay, but the goal is to get it into this form. Okay, so that involves a little bit of work, but not too bad of work, because we're just squaring a bunch of binomials, and then we're going to combine like terms to get y by itself. So squaring this y minus 5, I get y squared minus 10y plus 25 equals, square the x minus 4, I get x squared minus 8x plus 16 plus square the y minus 9, I get y squared minus 18y plus 81. Okay, now it's getting a little bit longer, but one thing that's really nice about these is, take a look, the y squareds cancel. There's one on each side, subtract from both sides to cancel. And we want that to happen, right? Because in our form y equals ax squared, there are no y squared terms, right? They should cancel, and they do. So I'm going to write down everything that I have left by combining all like terms that I can. So on the right side, the only thing I can combine are the 16 and the 81. So I'm left with x squared minus 8x plus 97, and then the minus 18y. Now I want to get y by itself. It's almost by itself on the left side, so what I'm going to do is I'm going to add the 18y to both sides to get rid of it from the right and move it over to the left. But I'm also going to subtract the 25 from both sides so that the y can only be by itself. Okay, let's reduce this further. Negative 10y and plus 18y gives me 8y. 25 is cancel. I'm left with x squared minus 8x, 72. Aha, notice I'm getting very much closer to my answer, right? All I have to do now is just divide everything by 8. And I get y by itself. So I left with y is equal to, and there's a 1 in front of the x squared, so 1/8 x squared. Negative 8 divided by 8 is negative 1, so negative x. 72 divided by 8 is 9, so I have my equation in standard form for that parabola. And you can type that into your calculator, and you can see that if you plot that and plot the point 4, 9 and the line y equals 5, that you have a nice parabola with a focus and directrix. Pause the video, write down anything you need to before moving on. Alright, so this is the end of Unit 6 review, and here's a summary of the most important information you should take away from this unit. You should be able to identify aspects of a parabola by examining its graph or its equation, so you'll be able to find the y-intercepts, the x-intercepts, the zeros, the axis of symmetry, etc. Okay, where it's increasing, where it's decreasing from previous review videos, and so forth. You should be able to state the domain and range of a quadratic function. Domain's always all real numbers, but the range is always based upon the vertex. Whatever the y-corner of the vertex is going to help you figure out your range. You should be able to completely factor a polynomial given any of the techniques we learned in the first video, and use those factoring techniques to apply the zero product law to solve quadratic equation. You should also be able to solve a quadratic inequality and represent your answer both algebraically and on a number line. You should be able to complete the square to find the vertex of a parabola, as well as within equations of circles. You should be able to graph a circle given the center and radius, okay, and also find the center and radius given its equation, so you may have to complete the square. And lastly, find the equation for parabola given its focus and directrix. I want to thank you for watching this video. I hope this was helpful for you. I look forward to seeing you in the next one. Thank you.